This is a brief discussion about perfluorinated compounds. These are commonly known as Teflons, Scotch Guards, Gore-Tex is an example. These are slick, water-resistant, and stain-resistant polymers, or you can think of them as compounds. Compounds suggest that it's more than one element. Elements are the individual building blocks of matter and of molecules. So let me just give you a picture of the units of a perfluorinated compound. The reason it is important to consider perfluorinated compounds is because they are so common and because they are beginning to show up and indicated in problems like cancer, behavioral issues, and infertility, and hormone disruption. So let's take a look at this molecule. It is made up of, this is one unit. Remember, these are polymers. So this is one monomer or one unit of a polymer. So this carbon bonded to fluorines. So the two in the middle are carbons and the big blue guys are fluorines. What is most important about this unit is that this bond, this fluorine to carbon bond, is very difficult to break. In biological terms, it takes lots and lots of energy to break this bond. And that is why these, when put together, make a polymer that is then stain resistant and water resistant. This is why water beads up on Gore-Tex and why your egg doesn't stick to the inside of a Teflon pan. Let me show you what these guys look like when you link them together. So the carbons and the little dots in the middle are carbons. The F's on the outside represent fluorine. And then on the very end is just a little water. So really how these are usually displayed is if you imagine that you've got a carpet. These fluorines stick to the carpet via their water, and the highly resistant end of the molecule sticks up into the environment. So, and these are stacked one on top of the other. These line the top of your carpet. Now, this means that if you spill something, it doesn't get down into the carpet, and it resists. It resists, and then you can wash it off. Now, here's the problem. One of the big problems with this molecule, this wonderfully charming molecule that does all these wonderfully useful things. This is not a molecule that exists in nature on its own. This is an industrial chemical. In other words, it was made in a laboratory, made in an artificial environment, and it was kind of accidentally made in the 1930s. And soon thereafter, they discovered all the wonderful properties this molecule has. You will find this molecule not just in your fry pans and on your carpet, but you'll also find it lining the insides of many cans and many food bags, like chip bags or fast food bags. The reason this is important is that these guys are used everywhere. The other thing that's important is, remember, this fluorine bond, fluorine-carbon bond, is extremely difficult to break. These units, these polymers, this lovely, useful molecule that's protecting your carpet, they're finding that it persists in your body and in nature for a very, very long time, simply because it takes so much energy to break the bond of the fluorine to the carbon. So this, my joke about this, it's not really very funny, is that Teflon is the chemical you invite to dinner, and it never, ever leaves. Not only does it not leave, but because it is so commonly used, it ends up in your life over and over again. So it isn't like you just have Teflon come on Tuesday once a month, and it never leaves. So, you know, it comes every day. So pretty soon your house is full of these little guys. They're under your toenails. They're inside your nose. They're inside your blood. There are some major studies that have shown that 90% of us have these molecules in our bloodstream. And these molecules have a half-life, which means half of this chemical has been detoxed, half of 8 years. So 16 years from now, you'll still have 1/4 of this substance in your bloodstream. And if you partake of Teflon in your life many times, you'll have just that much more to try to get rid of. The bad news is, that's of course bad news, but additionally bad news is that we don't really know much about this molecule because it didn't exist in nature. We're not very sure how it's bioactive. We're not very smart about it. What we do know is that it persists for a long time, and it's beginning to show up everywhere in the fat of penguins, in the deep seas of the Arctic and the Antarctic. This chemical is everywhere, and we don't know enough about it, but we do know, and we're beginning to understand that it's bioactive. Now, what about your pets? I mean, they only live, God bless them, they only live, to be 8 to 16 to 20 years old if you're just so lucky. And remember, these chemicals hang out, and dogs and cats are really close to the floor. Their nose is often on the floor, or under your cushions, or looking around, or licking your plates, and they're picking up a lot of these guys. So just consider this little molecule, how useful it is, and how we don't know much about it, and how these bonds are very, very difficult to break. And consider that if you do invite it to dinner, some part of this guy will be with you for a very long time.